The dream of flying cars is not new. For decades, it has captured our imaginations. We've seen countless concepts in science fiction. Now that future is finally within reach. The flying car is transitioning from a fantasy to a tangible reality. Early attempts, like the 1947 Convair Model 118 Convair car, showed promise, but they ultimately fell short. Technology simply wasn't ready. Fast forward to today, and the landscape has changed dramatically. Advances in electric propulsion, battery technology, and autonomous flight control systems have breathed new life into this dream. Companies around the world are pouring resources into developing these vehicles. Startups and established aerospace giants alike are vying to be the first to bring a commercially viable flying car to market. The competition is fierce and the stakes couldn't be higher. This is about more than just creating a new mode of transportation. It's about revolutionizing the way we live, work, and connect with the world around us. The dream is becoming real. Companies like Aleph Aeronautics and California-based Kitty Hawk are designing and building flying cars. These aren't just concepts or prototypes relegated to testing labs. They are real, functioning vehicles. Aleph Aeronautics has created a stir with its Model A. This flying car boasts a unique design. It can take off and land vertically, eliminating the need for a runway. It's small enough to fit in a standard garage, and it has a projected range of 200 miles. The Model A has already garnered thousands of pre-orders. Production is slated to begin soon. Then there's the Blackfly, developed by Kitty Hawk. This all-electric aircraft resembles a giant drone. It's classified as an ultralight aircraft by the FAA. This means you won't need a pilot's license to fly one. The Blackfly can reach speeds of up to 63 miles per hour. It has a range of about 25 miles. These are just two examples of the many flying car projects underway. Each company is taking a slightly different approach, but they all share a common goal: to make flying cars a safe, reliable, and accessible form of transportation. At the heart of this transportation revolution is a technology known as eVTOL. This stands for Electric Vertical Takeoff and Landing. eVTOL aircraft combine the best of both worlds, the vertical takeoff and landing capabilities of a helicopter with the speed and efficiency of a fixed-wing aircraft. eVTOL aircraft rely on multiple electric motors to power their rotors or propellers. This distributed electric propulsion system offers several advantages over traditional combustion engines. Electric motors are quieter, more efficient, and produce zero emissions. This makes them ideal for urban environments. The use of electric propulsion also simplifies the design and mechanics of flying cars. With fewer moving parts, eVTOL aircraft are easier and less expensive to maintain. This is a significant factor in making flying car ownership a realistic possibility for more people. The Achilles heel of electric vehicles, whether on the road or in the air, is battery technology. Current battery technology simply cannot store enough energy to power a flying car for extended periods. This is a major hurdle that engineers and researchers are working tirelessly to overcome. Most flying car prototypes have a flight time of around 20 to 30 minutes. This is sufficient for short hops across the city, but it's not practical for longer journeys. To make flying cars a viable alternative to traditional cars, we need batteries that can provide significantly more range. The good news is that battery technology is advancing at a rapid pace. Researchers are constantly developing new battery chemistries and designs. These promise to increase energy density, improve charging times, and extend battery life. It's only a matter of time before we have batteries capable of powering flying cars for hundreds of miles on a single charge. Section 5, Safety First. Navigating the skies responsibly. Safety is paramount when it comes to any form of air travel. And, flying cars are no exception. In fact, the stakes are arguably even higher because flying cars will be operating in more congested airspace, closer to populated areas. The margin for error is significantly smaller. To ensure the safety of both passengers and those on the ground, flying car manufacturers are implementing rigorous safety protocols. These include redundant flight control systems, autonomous emergency landing capabilities, and comprehensive pilot training programs. Before flying cars can become a common sight in our skies, they must undergo rigorous testing. This includes both physical tests and simulations. These tests push the vehicles to their limits. They ensure that they can withstand a wide range of weather conditions and potential malfunctions. Section 6, the regulatory runway. Developing the technology is only half the battle. Before we can all take to the skies in our flying cars, we need a clear set of rules and regulations to govern their use. This is where things get a bit more complicated. The Federal Aviation Administration, or FAA, is tasked with ensuring the safety of the national airspace. They are currently working on regulations specific to flying cars. These regulations will cover everything from pilot certification and licensing to airspace management and traffic control. The challenge is to create regulations that foster innovation and encourage growth in this nascent industry, but they also have to ensure the safety of everyone. It's a delicate balancing act. Striking the right balance will be crucial to the success of the flying car industry. Section 7. Reshaping our world. The potential impact of flying cars. The advent of flying cars has the potential to fundamentally reshape our cities and our lives. Imagine a world where traffic jams are a distant memory. You could commute from the suburbs to the city center in minutes, not hours. Flying cars could also revolutionize emergency response. They could be used to transport paramedics, firefighters, and police officers to the scene of an incident far more quickly than traditional ground-based vehicles. This could save countless lives. The possibilities are endless. We could see the rise of flying taxis, air-based delivery services, and even flying food trucks. The skies are literally the limit when it comes to the potential applications of this technology. Section 8. Challenges on the horizon. While the future of flying cars is bright, there are still some challenges that need to be addressed. One of the biggest hurdles is cost. Currently, flying cars are prohibitively expensive for most people. The Alif Model A, for example, is priced at $300,000. Another challenge is infrastructure. Flying cars will require a new infrastructure to support their operation. This includes landing pads, charging stations, and a robust air traffic control system. Developing this infrastructure will take time and significant investment. Public acceptance is another hurdle that needs to be overcome. Some people are understandably wary of the idea of thousands of flying vehicles buzzing overhead. Addressing these concerns and educating the public about the safety and benefits of flying cars will be crucial. Section 9. A future in the skies. The flying car is no longer a figment of our imaginations. It's a very real and rapidly developing technology. The progress made in recent years is nothing short of remarkable. While there are still some challenges to overcome, the future of flying cars is incredibly exciting. In the coming years, we can expect to see flying cars become increasingly common. Initially, they will likely be used primarily for commercial purposes, such as air taxis and cargo transport. But as the technology matures and costs come down, we can expect to see personal flying cars take to the skies in greater numbers. The dream of soaring above traffic and experiencing the freedom of personal flight is closer than ever. The flying car revolution is upon us, and it's going to be a wild ride.
YouTube,
Facebook, 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 Facebook.